In this video, we are going to look at the concept of congruence. I believe you watched the previous video on similarity. Similarity and congruence, they are somehow related. Now, congruence, this term is normally used in mathematics, but there's a simple word that means the same thing as congruence. And that simple word is equal. Whenever you hear the word congruence or congruent, we are talking of two things being equal. Now, let me quickly try to give a definition of what is congruency. Now, in short, we can say that congruence is actually the relation between shapes that have the same size of length. I'll explain further. Now, in order for us to move further, first we need to know under congruence, in most cases, questions can come in a form of whereby you are given two triangles and then you have to explain or prove whether the two triangles are congruent or not. Sometimes you may be asked to find the missing angle or maybe the missing side, but in most cases you'll be asked to find the missing angle and to prove whether two shapes or figures are congruent. Now, there are criterion that we can actually use to prove whether two shapes are congruent. Now, let's quickly look at the criterion. Now, the first one, I think I need to draw a shape. Suppose we have this triangle and we also have another triangle this side. Now, in order for us to prove if these two triangles are congruent or if they are equal, suppose this is triangle ABC and this is triangle DEF. Now, what we have to look at, we need to see to it that suppose this side here is equal to that side, and if this side is also equal to this side, you can see that these sides are corresponding. If that side is equal to that and this is also equal to that, and the third side is also equal to the corresponding side on the other triangle. If that is the case, all the three sides of a triangle are equal. This side equal to that, this equal to that, this equal to that. If that is the case, then we say that the two triangles are congruent. Therefore, that criteria is known as side criteria. All the three sides, you can see there are three sides. All the three sides are equal. Therefore, we can say that those two triangles are congruent. Now, the second one, suppose we still have two triangles. We can still use the same letters. Suppose this is A, B, C, D, E, F. Now, suppose this side here is equal to that corresponding side on the other triangle. And again, this side here is equal to this corresponding side on the other triangle, and this angle here is equal to that corresponding angle. What you can see here is that we have two sides that are equal. We say side, I think I need to use this one, right? We have two sides that are equal plus one angle. Therefore, we say that criterion is known as side angle side, or you can say SAS. Side angle side. If two sides are equal and one of the angles, two of the corresponding angles are also equal, then you can say that the two triangles are congruent. The third one, we can also draw two triangles. Suppose this is A, B, C, D, E, F. Now, in this one, here we had two sides that were equal plus one angle. Now the third one, suppose this angle here is equal to that angle, and this angle is equal to that angle, and then this side is equal to that. Two angles, two corresponding angles are equal, and one corresponding side are also equal. Then we can say that the two triangles are also equal. Now this criterion is known as angle side criteria. Angle side criteria. Two angles are equal plus one side. Therefore, we say those two are equal. The last one, when you have a right angle triangle, suppose they are two. When you have two right angle triangle, and then obvious, the right angle for every triangle, they're always equal. Now suppose you have two right angle triangles and you want to prove that if these two shapes are congruent or if they are equal. First you look at the right angles. Obvious, we know they are equal. And then you also need to look at one of their sides apart from the hypotenuse. Let's take this side here. If this side is equal to that side, the two right angles are equal and this side is equal to that. And if the hypotenuse is also equal to the other hypotenuse on the other triangle, therefore we can say that the two triangles are equal. Now this one, they say we are now using the right hand side. Not right hand side, but right angle triangle, hypotenuse, and then side. Right, the R is for right angle, while the H is for hypotenuse and the S is for side. If those three conditions are met, then you can say that the two triangles are congruent. Now let's look at one example to illustrate that. Now, suppose we are told that we have two triangles. Let's have one triangle here and then another triangle here, and we are told this is triangle ABC, and then here we have DFE, and we are given that this side is 6.9 centimeter, this side, the corresponding side, is also 6.9 centimeter, and then this side is 8.4 centimeter, and this side is also 8.4 centimeter. We are not given this side and that side, but what we are also given is this angle here is 45 degree, and this angle here, the corresponding side, this corresponding angle is also 45 degree, and this angle here we are told it's 54 degree. The other two corresponding angles we are not given. Now the question is, we need to show suppose this is A, we need to show whether triangle ABC is congruent to triangle DFE. That is the first question that we need to answer. The second one, we need to find angle DFE. That angle is this angle here, DFE. That angle, that is what we want to find after proving or showing if the two triangles are congruent. Now let's look at the solutions. Let's start with letter A. Letter A is very easy. It's very easy to tell. What do we need to do for us to prove if these two triangles are congruent? All that we need to do, we have to remember the 4 criteria. The first one we said side, side, side criteria. The second one we said, what did we say here? I think we said side, angle, side criteria. And the third one we said angle, angle, side criteria. And the fourth one we said the right angle, the hypotenuse, and the side. So what we need to do, let's quickly look at the sizes or the lengths of the triangles that we are given. The first one says all the sides should be equal, the corresponding sides should be equal. Now if we can check on our two triangles, we can see these corresponding sides are equal, these corresponding sides are equal, but the third corresponding sides, they are not equal. We are not even given by that matter. Therefore this one cannot apply. Let's look at the second one. We say there should be two sides that are equal plus one angle. This side is equal to that, we can see that, it's given. This is equal to that, it's given. This is equal to that angle. That means this can work. So what we can do, we can now say BC, this length BC is equal to FE. They are all equal to 6.9 centimeter. That information we have to say we are given in the question. The second information that we are also given is that AC is equal to DE. AC is equal to DE. that is equal to 8.4 centimeter. We are also given. And we can also see that these two corresponding angles are equal. And we are also given, so we can say angle, that is the symbol for angle, angle BCA is equal to angle FED, which is equal to 45 degree. We are also given. Therefore, we can now deduce by SAS, side angle side, triangle ABC is congruent, that is the sign for congruence, is congruent to triangle DFE. And then we are done. Let's look at the second question, letter B. The second question is asking that we should find angle DFE, that angle right there. Now what you can see here is that these two corresponding angles we are not given. Now how do we find that angle? Now what we need to do, if you can remember the concept of similarity, where we said you can find one side of the triangle if the other similar triangle, if the corresponding side on the other triangle is given. We are going to use the same concept here. Now what we can do, let's use triangle ABC. Triangle ABC. If we use triangle ABC, we can say, we know that by definition a triangle has all the angles inside the triangle should add to 180. Now in this triangle we are given these two angles, so we can subtract, or we can add those two and then subtract from 180. 54 degree plus 45. Now what we can see is that here we have 180 minus, we can add those two to get 99 degree, and then we can subtract from 180 to get 81 degree. Now what you can see here is that this angle that we are calculating here this is supposed to be, sorry for this is supposed to be angle ABC, supposed to be like that. We're actually calculating this angle here, ABC, because we are given these two angles, and we know by definition that a triangle should, all the angles inside the triangle should add up to 180. Since we are given these two, we add those two, we subtract from 180, and then we are getting this. And then we now use the concept of congruence. Since we have proven that the two triangles are congruent, if these two triangles are congruent, then it means that angle is equal to that angle. Therefore, now that we have found this angle, we can now say by definition that angle is also equal to that. Now we can say, since triangle ABC is congruent to triangle DFE, therefore angle DFE is equal to 81 degree. Please, if you do not subscribe to this channel, I will encourage you to subscribe. I upload new videos every week on different topics. Bye.